Hi, everyone. A very happy Tuesday and welcome back to our ARM Tech Talk series. This is the place for the latest and greatest trends, technologies, and best practices from ARM and our ecosystem partners. I'm so thrilled you could join us today for a bit of a change of scene from what we've had over the last few weeks. And we're going to be talking about, for the next couple of weeks, actually, almost exclusively automotive focused topics. And it's super exciting today to be joined by David from Sensory, who are going to be talking about the voice AI solutions they have and the collaboration and work they've been doing on the SOAFEE platform and with SOAFEE. So before we get to today's really exciting topic and today's talk, I've just got a couple of housekeeping items. If you've been to one of these tech talks before, you know the drill. But I'm going to get through these as quick as I can so we can hear from David and the team at Sensory. So if we can head to the next slide, David, that'd be great. So if you want to get involved in the conversation today, you can, of course, use the hashtag ARM Tech Talks, as well as tagging ARM and the on ARM hashtag that we use. All of our tech talks, including this one, are available on demand. So if you miss anything from today's tech talk, just head to YouTube, subscribe to our YouTube channel, and you can catch this talk and all of our upcoming ones there. We've even got a playlist of all of the past tech talks. We're well over 80 by now. So I think the next milestone is 100, which is super exciting. It's a great way to find out, what is the latest and greatest from ARM partners we've been doing this for the last 3 years or so. And if you like what you see and you want to get those first seats for the upcoming ARM Tech Talks, then head to arm.com/tech talks to do so. To give you a little sneak peek of what's coming up, if we head to the next slide, we have a tech talk next week from QNX, who are going to be talking about their work with ARM-based Graviton and their work with QNX Accelerate, which is really exciting. There is a blank space for the 28th of November, but I can confirm we're going to be having Open Synergy. That's just been confirmed. And we'll be getting that Tech Talk live very shortly. And we have some very exciting plans for the rest of the year and indeed for early next year. So do keep an eye on our Tech Talk page and with your marketing emails on just to see what we've got coming up. So that's enough from me. Before I hand over to David, and we'll see a little picture on the next slide of what he looks like, we actually hear from him in person in a second. If you want to ask any questions at any time and you're on the Zoom call, please do just use the Q&A box in the menu bar at the bottom to do so rather than the chat. Make sure we see them and we'll get to those at the end. So David, thank you so much for joining today's ARM Tech Talk. We're super excited to hear from you. Please take it away. Tell us about what you've been up to.
All right. Thank you very much. I appreciate the introduction, Tobias. I'm Dave Rich. I am in charge of both product and planning at Sensory. Sensory is one of the leaders in embedded voice AI, I guess I'd call it. But it's the industry in which I've been for most of my career. So I really want to share with you a little bit about speech, because now is kind of an interesting time. And I don't mean it just because, we think it's been the time for speech for the last 30 years. It feels like that if you've been in the industry dealing with the technology. But I would actually say, yeah, why voice and why now? Because there is a lot of conversation about this. Voice is basically the most natural and fastest form of communication. It's 3 times faster than we type. It's a very compelling and easy way to communicate. But really, why now? And what's so compelling about this? Well, the number one problem is the human-machine interface that we have today in most forms is not very natural. One of the problems, they require learning. If it's touching a button, moving a mouse, typing, instructing somebody how to navigate through a menu, it takes training, it takes learning, it's effort. So it's not just something that we learn. We learn speech when we're young. It's a normal form. And so being able to interpret that is very compelling for communication. Second is, for human-machine interfaces, an awful lot of them require eyes. It requires moving attention. So if I'm in a car and I'm looking at a dashboard, that's already a safety problem, because in 1 second you could potentially be traveling hundreds of feet, and that's a safety concern by itself. But then you just have to pay attention to just what is the UI. You have to move through menus. That's very confusing. So it's this cognitive focus that's difficult. Then next, there's limitations to voice. Voice very often, in the past at least, has been voice in, voice out. So most people think of it from a user interface perspective. I'm on the phone, I'm talking to somebody in a customer service center, I get responses by voice too. And I think we've all been trained by assistants to do the same thing. If we're using Alexa, we say, Alexa, and we provide a command, and what we get back in return is something that's oral. But that's also really constrained because, not everything is a communication. Not everything has to behave that way. So I would just say, why now then? Well, there's been a lot of advancements then in the core voice AI technologies. First, which has been going for a long time, technology from the hardware platform perspective is becoming cheaper and faster, but I think the portability is becoming really important. It's becoming smaller and easier to embed. And this is core to something like a car, right? These are just rolling cell phones. And at the end of the day, this rolling cell phone gets more and more powerful and has the ability to control and manage an awful lot of things in a car. So that's making rapid advancement. But more importantly, I would say in the last 5 years, speech-to-text transcription accuracy has increased very quickly. And that's due to new algorithms. We've gone from one neural model to another, from CNNs to DNNs to now we're doing more advanced neural-like approaches. And so accuracy is getting as good as human communication. And in some cases, it's even better, depending on the type of noise or environment it's in. Speech-to-text has been fragile to noise. There's a lot more noise mitigation strategies and ways to be able to handle background environments. So that too has made a difference in communication. Next, and also just as important, is natural language understanding is another element of speech-to-text. Speech-to-text provides a series of words, but the NLU is what provides better interpretation, or actually improving the quality of what those words are. And then being able to actually interpret it and figure out, well, if there's a context behind it, what does somebody mean? How do we disambiguate? The next really important one that we've seen in the last year, and I think this is the one that's the biggest driver of an awful lot of innovation right now, large language models. They are communication. We typically put in text and we get various types of responses that are pretty compelling and interesting and new for all of us. But the voice interfaces for those aren't great. They're not quite as well defined as they could be. But I think there's a lot of advancement and experimentation going on. So there's actually new ways to access whole domains. If I were to use ChatGPT and I could put constraints in it, I could actually create almost any domain. So I could tell ChatGPT to provide commands just like one would have inside of a car. And then if I ask a question or a command, it can actually provide the output well interpreted around what that natural language would be. So there's actually a tie between the speech interface and the types of things that a ChatGPT can do. And I'll try to demonstrate that for good here. And then finally, we're learning a lot more about multimodal communication. It's nice to be able to say something and have it returned via voice, but one of the most important ways we take in information is visual. So being able to say something and get responses by voice, or being able to work with other modal communications, is really, really important. And so the advancement of how we, just from a human factor standpoint, understand that is changing how we're going to be able to communicate with different types of devices. And I think this is really important in a car, because in a car, somebody is sitting there in an environment and they might say something, but their eyes are focused on a road. They're not going to be looking at a lot of other devices. But one of the things we can do is then assess, well, where is somebody gazing? Are they looking away? Are they looking at someplace else? So we can actually help maybe constrain where somebody's looking and the types of things that they need to know when they're looking in that direction. It can actually help focus the interaction via voice. So a lot of potential different things we can do in the multimodal environment. And then I think lastly, there's a lot of voice interfaces that are really critical when it comes to safety. We're talking about safety in the car. It could be anything from not being able to, not having to press to talk, not having to do anything in order to have a conversation. I can just naturally talk to the car. That's fine, but we also have new applications so that if I go off the road and have an accident, I can actually just say something via voice to go get help. I don't have to find a device, dial, press buttons, call. And that might be really important in those life-threatening times when somebody's been in an accident. Also then voice interfaces, mentioned 3 times as fast as somebody can type, very quick, frees up cognitive load. These are compelling for the why now. So let me talk a little bit about Sensory, because Sensory is a company that has been around for a long time. It's almost 30 years old, and it's really been known for wake words, or words to provide basic commands. So Sensory is in over 3 billion products at this point in time. They started actually with toys and toy interfaces. And so it's moved from there to being very advanced technologies, but the core of everything that Sensory has developed is embedded. It's on device. And while there are other areas where we have a lot of technologies in the cloud and in between the two, it's kind of the roots. We have a lot of customers. You see the logos on the right-hand side. A lot of them are automobile companies. They're first-tier providers. We've worked in this industry for a long time, and it is in the realm of wake words, which has been important, but also command and control. So our historical focus, while it's been consumer electronics, has really been shifting to automotive over the last couple of years. So Sensory Automotive for us incorporates a whole range of technologies that we've developed in-house. I'm not going to go through the branded names for all of our technologies, but I will let you know that they're pretty well integrated, and they're all the things needed in automotive. So that is where we are living right now in terms of the automotive world. We're on device. We do that because it is very possible to respond quickly. You don't need to go to a network anymore. You don't need to be connected in a car. That's very common in many parts of the world where you really don't have that level of connectivity. But just as important, privacy. So when somebody requests something, if we're going to include voice biometrics, that can stay in the car and not ever leave. So it's a vast improvement in the privacy stance of communication from inside of a car. And just as importantly, there's a lot of consumers who are now becoming a little suspicious of the voice interfaces and where that data is being used. So being able to assure somebody it's in the car is becoming increasingly important. We also then do access a cloud when it comes to dynamic content. That is, it's easy to request to have doors locked or unlocked. That stays on device. But if I want to know the weather, that's not going to be on device. So that, unless I look out the window, but it's going to go to the cloud and retrieve that information. So access to the cloud is really important. Next, there's the whole range of natural language. Natural language now allows us to not have to memorize commands. We can say anything almost any way we want, but those can now apply to command and control. So I can say all the variants of how to unlock a car, how to turn up the volume, how to lower the volume, and use a broad range of language. It's well understood. And so the other area where we've put a lot of focus then is language coverage. Cars are global platforms. They need to be able to cover a broad range of languages. There's about 40 languages that almost every car company requires coverage for. And so we are adding to all those dimensions. By the end of this year, we should be pretty close to that. I'll come back to that in a little bit. We also provide support for a range of use cases. And so this is the other part of our world besides voice is we do a lot of things related to voice and facial identity. We can identify sounds like emergency vehicles. Emergency vehicle detection is becoming increasingly important to know, is there an ambulance coming from back behind you? Because I'm in this nice insulated cocoon playing music, I might not know it. So creating more and more alerts in the environment is becoming increasingly important. And so sound ID is key to that. And then being able to use facial technology, both to understand where somebody's looking and how that is being further integrated into the overall voice and user experience for the interface. So we also find we partner with an awful lot of companies because they want best of breed. I mean, we are kind of the best of breed for wake words and on device. We have a lot of tricks, tools, and ways to be able to optimize that performance. And just as importantly, and one of the reasons I'm here is we're really excited about SOAFEE because we leverage SOAFEE across our entire product platform. And I'll come back to that in a few minutes. So part of what I'd like to do right now is show you some demos, because demos tell a story, and I can refer to what we're doing by telling that story. So hang on just a moment. I'm going to set up the demo. All right. Hang on. All right, so this is an automotive demo platform. This is not something that you would normally see anyplace else. But what I'm going to do is I'm going to have it listen. And what I have set up right now is a voice trigger word. We're using Voice Genie, which you see listed right there. And I said Voice Genie,
Sorry,
it recognized
David.
that and it's listening. Yes.
Sorry to interrupt, David. We'll just have it. We can't quite see the demo screen you're sharing. Do you want to just try and share that again? Sorry.
Yes, I will.
Because it is very exciting. I saw it in a little preview beforehand, so we don't want the audience to miss out.
We definitely don't want to miss out on that. Wait, that's better.
I can't see it. Do you want to just stop sharing just escape the slides and let's just switch to, there we go. Yep, can see it now. Fantastic. I'll hand back to you.
Thank you. All right, so now that you can actually see the demo, my apologies. So this is a demo platform for us. As you can see right now, it's listening for this wake word, and we say, and then Voice Genie. Now, the moment I say Voice Genie, the platform will listen. So I can start it. Say Voice Genie, open the windows.
Opening the windows.
Voice Genie, open the windows halfway.
Opening the windows halfway.
And I'm going to stop it right here just to show you that I could say this many different ways. I could say a number of things, but what we're really trying to do in all the things we say is we have to recognize the words correctly, but we also want to recognize the intent, which is essentially a verb. And the entity ends up being both, think of it as a noun and a bunch of descriptors. So it gives us the ability to say, okay, we're talking about opening windows, that's the action. And the descriptor then is, well, how much or in what way. So let me provide a few more. Voice Genie, set the cruise control for 70 miles per hour.
Setting cruise control to 70 miles per hour.
Now you might notice the speed is pretty fast. This is actually running all on a tablet right next to me. So it's not running on my laptop. It's this separate device, and you probably can't see how it's running here, but part of what we do is try to do everything where we set up demos. They run on device so we can show how something's performing and the level of speed. So Voice Genie, open the trunk.
Opening the trunk.
Voice Genie, close the trunk.
Shutting the trunk.
And you'll see things flash across the screen initially when I give a command. And the reason for that is voice is being recognized in a string. And as it's recognized in a string, it has to take the context of all these various utterance components and comes up with the best possible decision for the entire string. So you kind of see it going through some of that magic. You would not be seeing this if you were in a car. The car would just do it. So Voice Genie, turn on Spotify.
Now playing Spotify.
Voice Genie, skip to the next track.
Adjusting the music as you requested.
Voice Genie, navigate to the nearest gas station.
Showing directions to nearest gas station.
And so as you see it, what it can do as well is that you can integrate it with other types of platform components and start bringing them up in the very process. So we haven't really integrated with other things, but the intent and entity ends up being a map for an automotive manufacturer to be able to determine what actions to take within a car. Voice Genie, I'd like to send a note to Jeff to let him know that I'm running late and I will be there in about 20 minutes.
Sending message.
So it brings up a message format. I can click on, who it is, but basically it's showing and it would automatically be set up with a list of contacts. I could have the message sent directly to Jeff at that point in time. What you're seeing too at the top is this is speech to text. Speech to text needs to be really accurate to be able to do good recognition. That high quality recognition is what gives you a good intent, good entity. So a lot of the trick of working on device is that we need to be really efficient and get high quality with minimum resources. So that's one of the focuses of our company at all times. All right, I'm going to shift a little bit, and I'm going to go to a different demo. Second here. We also do facial and voice recognition. It's also really important in a car, because when you're in this car, you have to think about what are the various ways that you know who the driver is, because it could be pretty confusing if there's commands being given. So I could say potentially voice genie, and then I could have like my kid in the back seat want to open the sunroof. I don't want the sunroof opened, or it could be a safety issue, like move the mirrors. So what we want to do is be able to recognize not just a command, but often it's important to recognize who is saying it. And we also do facial recognition, because facial recognition is highly integrated with voice and can be correlated for a whole bunch of different reasons. So this is just a basic demo of those capabilities. First thing one typically does, and it's very simple, is add a user. So if I want to add a user, I can add a basic word. I'm not going to use a really long German word. Let's try something like recognize me. Okay, so that's going to be my keyword today. So what I can do is look here, and I'm going to start the recognition. So recognize me. Recognize me. Recognize me. I had to say that 3 times, and during that time, it created an enrollment, and that enrollment has 2 things. It took a lot of pictures of me, so it's going to be able to recognize my face, and it also then set up a voice print for me. So if I go to an application, these are some potential demo application types, but just a phone lock. I could say, recognize me. And so recognize the voice, it recognized me as a picture. And so if I do the same thing, but it's not aimed at me, recognize me. And it's looking for me, doesn't find me. I registered with my glasses on. So now I'm going to take my glasses off. It recognizes me right away. So that's one of the tricks, is you have to be able to work in a world where people might register one way and then need to use the technology in some other. And I'll do one more here. It could be just facial recognition. It's very fast. And so it's kind of hard when you realize how quick it is. It can go from many different angles. I'll change the angle on this again. I'll try one more time. It's very quick. So one of the nice aspects of being on device is it's quick, it's easy to see, easy to understand. So I'm going to move to one more application here. Hang on just a moment. Hopefully you can see this one. It says Sensory Cloud. I have this actually running in the cloud environment, but our cloud is the same as what we run on device. It's one of the really important reasons we're using SOAFEE. And this is a voice assistant. Now the voice assistant is set up right now so that it goes to ChatGPT. So what I'm going to do is I'm going to start this, and I can start talking. So what I can do is at any time I can say, "Hey Sensory." Excuse me, I better pick up my wake word. I have a wake word, "Hey Sensory." I'm a voice assistant, and what I'm trying to say is I'm going to be an automotive voice assistant. What I want to do is close this and start. "Hey Sensory, close the doors. Okay, my apologies. This is not going to work, so I'm not going to spend time on this right now. It's not the program. I'm having some problems with my laptop, so we'll just leave it at that. Okay. So come back to the presentation here. I can show you a lot more demos, but what I wanted you to see is the nature of the technologies that we have. So let me talk a little bit about what those technologies are and what they include. So the first area that's really where we make a reputation is wake words. Wake words are not easy. It requires a certain amount of length, variation. It needs to be always running in the background, so it's very low power, low latency, can't take up a lot of CPU power. So when we talk about Google and we're talking to Alexa, those are always listening wake words. One of the hardest ones to use, and Apple's moved to this recently, is what we call enhanced Siri. It's gone from Hey Siri to now just Siri. And when you think of that as a background word, well, if I say seriously, well, Siri's in the middle of that. And so it's really important that we know how to listen to silence on each side and be able to pick out Siri as the spoken utterance. And we passed that for one automotive manufacturer across 10 languages. So developing wake words means we develop it for by collecting a lot of data. We develop for a language. We have to collect data in multiple languages because it's spoken differently in different languages. So it's this multi-dimensional platform. And that's, I would just say, the foundation. Next, beyond that is we can do beyond wake words, various types of commands. Those commands can be a limited language set up to about 40 words. Those can basically trigger at a point where in a program, you stop and listen specifically for a range of different words. So those could be simple commands. What we're moving towards almost across the board is these commands using natural language, because you don't have to memorize exactly the word or way something is said. So natural language speech to text on device is with intent and entity is kind of the basics now for most upcoming automotive applications. One of the things that's really important, though, is if I'm always listening for an automotive command, that's simple. But what about when I say, voice genie, I want to know what the weather is? Well, the automotive data set and language model that's loaded needs to recognize that it isn't in the automotive domain. I'm looking for something outside of the automotive domain, and I need to have that conversation sent somewhere else. So there's work that needs to be done on device, be able to direct the inquiry from the device to the cloud, be able to retrieve that information, bring it back, and interact with it at that point in time. The next element that's really important is how do we layer in voice biometrics? Because voice biometrics aren't just for security or transactions. This lets us identify that, for example, a registered driver who has a voice print can be recognized by the car as the person actually in charge of the commands for that car. And then be able to shift that with a profile. This is about personalization. Shifting that profile so that when I'm driving, there's one set of voices and voice commands, and it listens to me. When my wife drives, then she has a separate registration profile. It's going to listen to her, and it can go on and on for approved drivers for a particular car. So that's also becoming a pretty basic capability in automotive that you're going to see proliferating on most platforms in the next couple of years. The next element that's really important is just efficiency. An awful lot of the platforms for cars are still pretty beefy and hefty. This is a technology that requires quite a bit of memory, quite a bit of processing power, and we're extremely efficient and small. We have some models that operate for wake words, for example, in the kilobit range, a few kilobits. But we go all the way up to very large models for recognizing large domains or wanting to increase accuracy across large domains. So we have really efficient performance, for example, with some of our extra small models. They're very effective at 20 megabytes. We have medium large models. Those are much larger. It basically has higher quality recognition across a range of different communication, because this is natural language, but it actually improves accuracy. And then one of the things we also have, which is just key, is having TTS. We have TTS across every single language that we are offering, and many voices. So those are the core technologies right now for automotive. Our language coverage is pretty much global. As I mentioned, car platforms cover all the major economies. Some companies sell more in one region than another. And one of the largest and most important ones right now is the Chinese market. That's where many EVs are developing, but platforms across North and South America and Europe require a broad range of languages. And it means the quality of the language needs to be very high. So we have a broad number of these languages. Right now, we have multiple forms of English. For example, we have US English. We're in the process of Australian English. We have a model for Indian English. UK English is in process. So even across English, there's a lot of variance. And the reason why we do that is it increases the accuracy of the communication, because for any communication in the car, you want to have something that's going to be in the 90% or well above range. You need to have high confidence that whatever you say is going to be recognized or recognized well. So as you look through the range of languages, probably makes sense. These are all economies, all common areas where a lot of cars are sold, often high-end cars as well. That list will keep increasing for us. By the time most voice companies have reached 60 languages, they've got extremely broad coverage across the world. One of the things we also do is we benchmark our technology. And so we've taken our fairly large model, it's a fairly rich one, and that's the one that appears in blue. And we've benchmarked it against one of the more accurate competitors right now in the market. When you look at the speech to text, it's using what's called the Mozilla Common Voice version 13 test set, and without training on that, because that's cheating. We don't train on it, but we do actually measure across that set. And so benchmarking against the major languages, these are some of the best ones, we perform well. And so one of the really important things when you look at accuracy on the left-hand side, we kind of actually typically measure it in the inverse. We look for word error rates. So the word error rate is often, let's say, 4 or 5%. If it's 5%, that means the accuracy is 95%. So word error rates, or in Asian languages, character error rates, we're trying to compress those and make them as small as possible. So that's our typical measurement. I do want to give you just a very quick run through of what is the magic that we do when it comes to speech to text. And I realize this is an eye chart. I'm not relying on you all recognizing this, but the dotted box there is actually everything that happens inside of the magic box. On the very left-hand side, we have an audio source. And what we take in is 16-bit audio that's sampled at 16 kilohertz. That's a pretty common standard for most automotive applications. And when you move to the far right-hand side, what do we get out? Well, what we get out of that is a transcript of audio that's encoded in UTF-8. We get words that are scored, and they're aligned directly with the audio stream. So we know, we'll call it a word confidence level when we say scored, but that could be a little bit misleading. Word confidence levels generally give you an idea of, is it the right or wrong word? And that's what we're looking for. And then there's results of any actions that might be found. And I showed you that when it came to the intent and entity. So what's actually happening? Well, if you move to the left-hand side inside of the box, we call this the first thing that happens is we send the audio samples to a feature extractor. And the feature extractor basically converts the time domain to a frequency domain. That's kind of a simple way of standardizing the signal and the speed and everything else that we're having to deal with. So we kind of create a standard model. And then we produce one frame of features at regular intervals. These features then are something that we actually put into a context. So all of those become standardized. Once those features are extracted, we feed them into the acoustic model. The acoustic model is something we generate. It's the first basic major model for a language. Every language has its own acoustic model. It's what allows transcription. And so our process is we go through think of it as a transformer-like recognition model. A lot of companies here use DNNs, CNNs. We're using something that's frankly a generation beyond those, which is partly how we get our accuracy. But that conversion is probably one of the most important elements of this magic sauce that we put together in here. Then we actually then do estimates of the likelihood for each language token. So we've got all of these features which are kind of tokenized, and so we look at the likelihood of what each of those might be for appearing within a sequence, and then we produce a mathematical formula of probabilities. So we take that and move it to the beam decoder, and what that really is doing, that's our language model. So at that point in time, we find the text that best fits the acoustic model evidence. So we're looking at the mathematical model, and when we say a language model helps put together and understand more of the words, and especially specialized vocabulary. So what we get to do is change sometimes the weighting of words and the probability that they're going to appear in a certain dialogue or in a certain context. So we have a lot of things we do around language models, depending on whether they're general for speech or text, whether it's specialized for automotive, whether it's specialized for banking, for medical, and even those have many sub areas. So all of those become specialized language models, and they're built in conjunction with the acoustic models. They go directly together. But we use that model to optimize the vocabulary. We can add in some custom words, but what it does is that produces the UTF-8 encoded text. And if we're going to do the additional effort of NLU, which is really going to help find what the intent and entity is, we run them through classifiers, and then we get to take that information and send it to a lookup table. And that lookup table is actually what then tells you what action do you want to take on the information that's received. And that's how you get from these very broad range of things that are said to understanding exactly what the words are correctly and being able to then parse those into the proper intent and entity. Now, that's a highly simplified form of what our speech scientists do, but with that, they're able to build very high quality models and make an awful lot of tweaks and adjustments to improve the quality of the recognition in a certain car environment, because cars have, each one has its own interior signature of how well it works based on where the microphones are placed, the type of microphone, the acoustics inside of the car. All of those need to be accounted for. And so an awful lot of our adjustments end up being, where do we want to set our adjustments for false accept, false reject types of features when it comes to, let's say, a keyword, or for recognition itself, how do we optimize that recognition? So our next major area where we're doing some work that's really important is around sound ID. And sound ID, we can actually recognize hundreds of sounds. Sounds are modeled very similarly to voice biometrics. We can have a whole range of training for, let's say, sirens from a country or from around the world. We can collect all of the audio, it's tagged, we build a model with that, and then we can actually play a sound and have it recognized as, yes, that's actually an ambulance in the background. And so the trick is, well, even in deployment, where does that microphone get placed? Is it outside or inside of the car? Can we tell which direction it's coming from? Those are all the things that are becoming increasingly important in the automotive space. Is how do we use various types of sound recognition, which has come out of much of the science for voice technology, to be able to improve alerts and awareness for what's around somebody. And that deals with even things like when a car is parked, are the things we want to recognize and be able to alert our driver to. The other technology that's becoming increasingly important in cars, with cameras in most cars and IR cameras, there's a lot of work being done around head pose, gaze, where somebody is staring actually can give you a score, first of all, just for attention. And there's many things that go into attention, like, am I eating? Am I looking off in the distance? How much time am I spending looking at the distance? Am I looking away for a long time or a very short period of time? So all of those components come together to create some scoring around attention assessment. But gaze can also be used for a lot of other interactive things with voice. And I think that's still pretty early in development, but there are a number of things being used to be able to look in a certain direction and be able to combine that with a voice command to improve the probability that a command might be recognized, because you're looking in a certain area. Like if I'm looking at the upper right-hand quadrant of something very briefly and saying, I want to turn down the music, I know I'm looking in the direction of music. It would be much easier, and we'd have a higher probability of being able to act on whatever's in that constrained area of vision. So that's our hope around gaze. And again, very similar technologies. So often these are similar to voice signals and regression around voice signals. It's also done with real-time eye tracking and real-time head position. So I haven't, I'm not going to play a video here, but what we do is we take our technology, we can actually identify, as you look at the dots on this, we can identify distances between various facial features. And we try to pin, especially where is the eyeball, where's the corner of the mouth, nose, and we can use a large number of dots or feature sets to determine, is someone looking to the right, to the left, up, down, where are their eyes focused? So we can actually start tracking where is somebody looking at the time. Again, very, very key technology, and I think you'll see a lot more of this coming up in the next couple of years. So one of the things I really am appreciative of is that SOAFEE has been very helpful for us. We've been members of SOAFEE for quite a while, and why it's relevant for us is, yes, we're developing all of these technologies we develop on device, and SOAFEE is supposed to be for containers in the cloud. Well, that is actually our important use case. So we leverage it across all of our products. And what we've done is we've defined a standard SOAFEE platform in a cloud, and we run it in a container. And if we build it in the cloud, which is a pretty easy place to do it, we can do it with higher compute, then we can actually run it on device in a smaller environment. So we can run it in car, we can run it, in fact, our entire stack in a single container in the car, and lets us manage resources. So the key importance is not just build once, deploy anywhere, but it also assures a greater level of reliability across devices. And it actually reduces some of our effort in deploying products. And for us, it's just as important, it's cross-vendor application, because SOAFEE is a standard, and that makes it much simpler to work across a lot of manufacturers. We do use a Docker, basically an ARM64 Docker container. That's what we're using for our dev work. I'll show you something about that in a moment, but it's creating predictable performance. We can put everything in this container, run in similar software, and we find, really a cell phone on steroids in the cloud is what we need for really our target platform anyway. We've also been working with ARM in many other areas, but we've got SDKs for the Cortex M55 and Ethos U55 underway. We work with Helium and the Helium support to do some acceleration along with custom ARM acceleration. So, we're working with ARM in a lot of different areas. We're trying to apply as much as we can to the SOAFEE environment. I just want to give you a little bit of a look at what we're using. This is actually a picture of our dev server by specification. So we use an Ampere Alta platform. So it's not super powerful. It works reliably, and we have a whole line of these that we use to operate. So I wanted to just come here to conclude very quickly. I mean, right now, voice is incredibly interesting, because as we add ChatGPT, the new use cases are going to be things like how do we actually get an LLM running on a car? How are we going to do that in conjunction with LiDAR? And why would you run an LLM in the car? Well, it'd be a really easy place to put an automotive manual. And then if there's a really accurate speech-to-text engine behind it, I can make a request to say, what form of, what does the light mean that looks like a little tire in my dashboard? And it can go to the automotive manual and describe what that is. Or more importantly, I could say, the check engine light came on and I've got thumping coming in from under the hood. Well, you can also in the LLM tune it with various types of diagnostics or other information that's been collected. So I think you're going to find that the information that's custom to a car will start becoming much more available in a natural form. And so having that very natural language speech to text input to the LLM on device in the car is more than just privacy. It's going to be speed and the ability to get information even when I'm not connected. So that's going to be a very useful aspect of the next generation of ideas that I think are going to be realized in the car. For our technology, we tune everything for low power, minimal compute, and high accuracy. So we kind of have this trade-off we always work across. We can vary models in size. We can pull out any of our range of technologies from wake words to commands to natural language commands to natural language speech to text, text to speech. All of those can be adapted based on size. We also quantize things. We put it on chips. We go to fairly low levels. We can operate on the CPU, GPU, and FPGA. So we operate in a lot of different platform levels. We as Sensory are a leader in accuracy in what we do. We are definitely a leader on embedded technologies, and we are becoming a leader in a range of different dimensions of the automotive space. So that's all I have for the moment. I would be happy to field some questions.
Let's get to questions. Thank you so much, David. An awesome tech talk. I always love demos. You know me, and those who watched them before, these demos are really exciting. So super glad you could show this, and really great to hear a bit about SOAFEE as well and your use of SOAFEE. So fantastic tech talk all around, and we've got about 10 minutes or so for questions as well, which is great. I've got a couple. I know we've already got some already in from the audience, so I'd love to get to those. But there's a couple of things I really want to cover first, just to make sure it will spur a couple more questions even from the audience. So what I'd love to understand a bit more is, you talked about the ARM devices and bits and pieces through there, and obviously demos that you showed off. What sort of amount of memory and processing resources are required for speech technology on these kind of ARM devices, do you find?
Yeah, it's a great question because to be honest, there's some elasticity to the size. So we can have models that run on less than 100 megabytes doing full speech to text. And we can go much smaller if it's just wake words. We can go literally to one meg. I mean, it could be very small or smaller. So it depends on the range of technology. As far as compute power, I've got a few things that I looked at here, but basically 2.6 gig CPU cycles to about 9.6 is kind of the common range, I'd say. So it doesn't take a lot of compute to be real time. And this is all about real-time communication. So I don't know if that gives you a good answer, but I mean, our largest model right now, a model set would be probably somewhere around 500 meg, a little more.
Awesome. That's really great to hear, and it's super interesting to see the kind of breadth that you span there. And I'd also love to talk a bit more, perhaps at a higher level, and your thoughts on and it's a big topic that a lot of people are interested in. We even did an ARM TV session on generative AI a few weeks ago. I'd love to get your thoughts on generative AI for automotive and the user experience there. What do you, as Sensory, think the impact will be?
I think it's going to be huge, and I don't think all the use cases have been uncovered or covered yet. I think the biggest challenge right now is that we have some really good cloud-based generative AI. It's just starting to merge in a form that's small enough, but it needs to become fairly compact and low resource. as they become smaller, I think what's really compelling in a car is you could have an LLM in a car that has a lot more than a user manual or diagnostics. You start looking at personalization. It can track what are the things I'm typically doing. If I come in a car every day and I'm checking the stock quote for 5 stocks, well, then I know that's actually what I'm having to look at, and it tracks it, and it can even potentially bring those up automatically. I don't have to ask for it after a while. But essentially, the car can be trained to the person. And so it's going to be more than just that user experience. And it might even be when I drive, I'm a really stressed driver. So I want to take not the fastest route. I want the route that's going to be most relaxing. Well, that's something that's going to take a lot of compute, and it's not something generally available from Google Maps. But if I'm going certain ways, or if there's information in mind and it can be incorporated based on experience, suddenly I can drive the way I want, and I can feel a whole lot better about this experience. So I think it's another level way beyond LiDAR or automation. It's how do we make it learn around a specific user's experience on a regular basis. I think that's where it will be incredibly interesting.
Absolutely. Thank you. That's really great to, really interesting to hear. And now let's turn over to the audience questions. And I think the first one you kind of hinted at already regarding the change of the voice trigger. So this is from Krishna, who said Apple recently changed the voice trigger from Hey Siri to Siri. And you mentioned this a bit in the talk. Any further thoughts on this? Any further comments about this, given the detection success and false alarm issues from when you change a voice trigger, when you change a wake word?
Yeah, I think the biggest challenge is you want it to be long enough so that it's a decent voice sample, and you don't want it overlapping with a lot of other things, because that's what gives you a false trigger. Siri is, to be honest, a really bad wake word. But it's what they chose. It's their choice for branding. And Hey Siri was decent because it was unique. Now that it's just Siri, it's actually just a lot more challenging. So for us, we pass these tests. Very few companies can do a Siri wake word, and it's very hard to pass Apple's test. Apple's still trying to figure out what the test should be and how to do it. They actually have a series of 6 tests. We pass all 6 tests in the process, but a lot of them are how the word is recognized in noise of various kinds, how well it's recognized within even general conversation. It will probably, enhanced Siri, as we call it, probably will have some falsifiers that are, it's going to be a little bit more than Hey Siri's been. But if you're looking for the right amount of pause in each side and you have confidence around how to listen for that, it improves the accuracy quite a bit. But it's going to be it's more of a challenge, but Apple wants to brand it that way. So we're going to make it possible.
Thank you. And we showed a demo there with the hardware platform. Someone's asked, and this is Sahana, and apologies for any mispronunciation, what the hardware platform that you used for the demo was.
Yep. This is the one we're using. It's AdLink. It's an AdLink platform. And we could potentially put a link in there later on. But if you do a search for the AdLink platform, it's a standard build, and it's pretty easy to acquire.
No, it's really great to see you using the reference development platform from SOAFEE. So yeah, super excited by the work you've done there for sure. And then Camille asks, 95% accuracy looks great. When you're thinking about safety, what would you need to get to 99%? Can you be achieved with bigger models? And if so, how much bigger? Or are we starting to get saturated at this level?
Actually, that's an excellent question. Over the years, we've always said, well, every percentage improvement in speech was an exponential effort. The amount of work to get that little bit better accuracy took a lot of work. I would say we've made huge strides because we've improved a range of different things that all work together. For example, natural language provides hints back to the language model. So it kind of knows a sentence structure which has a noun and a verb and something, limits what probably is the word coming next. You're not going to string together verb, 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 verb. So being able to use all those hints back simultaneously when you're coming up with a string of words improves accuracy. So what we do is we keep improving some of the techniques, we keep improving the algorithms themselves, and at the end of the day, training data too. We keep using more and more training data, and the availability of that training data improves accuracy. As we get to 99%, you're starting to hit a threshold that's above human communication, because we don't hear all of that as well. And when you consider background noise and how we handle that, I think I would even qualify it and say, what we're going to see bigger improvements on will be things like being able to understand voice commands on a factory floor when you can't even understand me if I were talking to you, because we can now eliminate a lot of the noise in the back. We can pick out the command. And some of that may be using multiple microphones and be able to just literally eliminate that noise with some separation. So, I would just say, if we can get most of these models in the 90+% range, in fact, my rule of thumb has always been 85% or better is useful. Below 85%, I consider it ageist. You kind of get the idea, but you may not have it right. As you get to the 90 to 95% range, you're pretty confident of those words, you know what it is. As you're going above 95%, somebody can actually build confidence in knowing the right thing is going to be understood. You don't have to have quite as much confirmation coming back to you. And so as we squeeze out that last little bit, I think we'll always see some improvements. We'll see better algorithms, but we'll see a broadening of accuracy in a range of challenging environments. And so I think that's where you're going to see the biggest change in the next few years.
Amazing. Thank you so much, David. And because we've only got 30 seconds or so before we have to wrap up, and there's questions still coming in, do you want to just mention to people how they can get in touch with you to ask their questions? Because I'm sure there's going to be tons more. It's always the way we get to the end and then more questions come in. I'm like, no, we're running out of time. I'm so sorry. I'm sure people want to get in touch with you. How can they do that?
Yeah, two ways. You can go to sensory.com. Please feel free to go there directly. You can send an email to them. You could send an email to me directly. That would be fine. It's D-R-I-C-H, so D-Rich, at sensory.com. Very simple. Email me. I'll get back to you as soon as I can. I'm actually traveling right now, but would be happy to answer questions or guide you in some other direction. I've worked across a lot of different speech companies. I know basically who can do what, and we have certain capabilities and others have theirs. So happy to converse with somebody about that.
Amazing. Thank you so much, Devin. Thank you so much for some really, really great questions. It's always amazing and always brilliant to see so many questions come in. So thank you, David, for an awesome presentation. Thank you, audience, for your great questions. And we'll see you again same time next week for another of ARM Tech Talks, where you get to find out all the latest and greatest trends, technologies, and best practices from ARM's ecosystem. As you saw earlier, next week's talk is from BlackBerry QNX, so do make sure you register for that. It's on arm.com/techtalk, so make sure you get your registrations in now so you can secure one of your places. David, again, thank you so much again, and audience, we'll see you again same time next week. Thanks, everyone.
Thank you, Tobias. Bye-bye.
Bye-bye.